In this video, I'm going to use the principle of minimum potential energy to derive the finite element method for our 2D rectangular element. And in reality, this is going to be just a review video because everything we're doing, we've already done, and there will be no changes between what we're doing for the rectangular shaped element and the triangular shaped element we've already used the principle of minimum potential energy for. Remember, our total potential energy stored in our system or in our element is the total potential energy due to the strain energy stored in the system minus subtracting off the work that has been done by body forces, by surface forces, and point forces applied at the nodes. Our total strain energy is the triple integral over the volume of our element of the dot product of shear and strain. You can do a dot product by a column vector, a row vector times a column vector, or a column vector by a row vector. Either way, what we're basically saying is the same thing as this scalar value. It'll serve our purposes better to think of this in terms of two vectors multiplied by each other. Likewise, the form for the integrals for our body forces, or work done by our body forces, work done by our surface forces, and work done by our point forces is unchanged from what we've done for the triangular shaped element. So substituting in all of the approximations for stress and strain that we derived in the previous videos, again, the form of an approximate value for the approximate value of the total potential energy stored in my system is more or less the same as what we did for the triangular shaped element. The only difference now is that our B matrix and our N matrix is somewhat different. Likewise, our displacement vector now has 8 values instead of 6 values. Our B matrix is now a 3 by 8 instead of a 3 by 6, and the form is the form that we derived in the previous videos. Likewise, the shape function is now a 2 by 8 instead of a 2 by 6, and the form of the shape matrix we've seen in the previous videos. So now I have an approximation for the total potential energy stored in my system. My next step is to apply the principle of minimum potential energy, which is that the values for my displacements, my displacement vector, which will minimize the total amount of potential energy stored in the system, is the actual displacements that will actually occur. So what I'm going to do is I'm going to take the derivative of this function with respect to my displacement vector and set that equal to 0. I'm going to get this equation as a result. This equation is exactly the same equation that we found for the triangular element. Again, the only difference is that the B matrix here and the N matrix here is a slightly different form and the form and the shape we've discussed in the previous videos. But the matrix, the equation itself is unchanged.